I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
One of these days.
Let's talk about the tone control in this Philco 60B. It's this unit right here consists of a switch and a wax-filled block right here. And the knob in the front of the switch just has two positions. It has higher frequencies. It has a brighter tone and a darker tone. With the higher, and the difference between these two is in the brighter tone, the high frequencies in the sound are allowed to come through and be put out the speaker. When you switch the switch in, you're adding a capacitor to the circuit which filters out some of the high frequencies, leaving you with a more bassy, but it's not really bassy, it just has the normal signal with its high frequencies clipped out, removed. If we look at the schematic, we can see it at work right here. Here's the output of the output tube, the 42 tube, pin 2, the plate. And the plate goes over and drives, as you would expect, the primary of the audio transformer, the output transformer, right here. So the signal goes from the audio signal goes from the plate of the 42 tube to the audio transformer, the output transformer. But right here, connected here, and permanently attached to ground is a 0.01 microfarad capacitor. That makes the sound less tinny. That filters out some of the very high frequency noise that you would hear, or high frequency sounds that you would hear, and makes the radio sound warm. If you want it to sound warmer and more bassy, you flip this tone switch, which couples in another capacitor, this time a 0.015 in parallel with the 0.01, and that gives you that more than doubles the capacitance and takes out even more high frequency sounds. So if this switch is closed, you get a very, to my ear, it's a little muffled, but a very bassy sound. When the switch is open, you get a higher, brighter sound. If you wanted to listen to conversation, you might leave the switch open. If you wanted to listen to music in rich tones, or seemingly rich tones, you might switch, or turn the switch closed and get a warmer background sound. So that's how it works. There are two capacitors in here. One is connected directly to the plate of the 42 tube, which is over to the left of your screen that you can't see, over that way. The other capacitor is connected to this junction right here. And let me zoom in a little bit. So when the tone switch is here, you're only using one capacitor in this circuit, and that's this one right here. So this guy is filtering some of the high frequency sounds to ground. When you flip the switch up, this comes up here, contacts this lead, which is a smaller black lead, hard to see back in there, but there it is. That adds another capacitor in parallel to this one, and you're filtering even more high frequency out. So what I'm going to do is I'll desolder that one. I'll cut this one because I don't want to have to dig the wax out to get to it. I'll cut it, and I'll recouple it to the lead of the new capacitor when we put that in. But then I'll get the wax out, pull the caps, replace those, put new ones in. I think in this case I'll put the wax back in if I can gather enough of it, and melt it, and then reconnect this lead to the new cap, and then pour in the new wax and clean all this up. But that's I just wanted to give you an overview of what the tone switch does. I'll pull this out and show you what it's like once it's out. Okay, I just clipped that lead. I desoldered this one. I could have waited until after I got this out to desolder that, but I didn't. I'll loosen this nut here. And this should come out. Big star washer between the switch and the chassis. I have to remember that. I'll just put it right there. Okay, there's the switch. It's really straightforward, and it's out. I used a little butane torch. Get these anywhere, rather than a heat gun, and it just popped right out, so no problem. Didn't melt a bunch of it around either. And I'll save this paper. There are the two capacitors. I'll save the paper. There's a little bit of wax in here. Take that out. Now we can restuff the tone switch. I've got it cleaned out. I lubed it so that this would switch back and forth. Still stiff by my fingers, but it works. Put a little bit of white lithium in here. This is the detent, just to keep it in one place or the other. And now I'm ready to put capacitors in it. So the schematic, as you'll recall, calls for a 0.01, this guy right here, to be in circuit all the time, and this 0.015 to be switched in and out. Now I have a 0.01 right here. Probably way too small a print for you to read, but it's 0.01 microfarads. I do not have a 0.015. However, I do have another 0.01, and I have a 472 capacitor, which is 0.0047. So if I put these two in parallel, 0.01 and 0.0047, I will have a 0.0147, which is darn close to a 0.015. So these two guys will go in parallel. They're different sizes because they're different makers. This is 630 volts, and this one is also 630 volts. So just a different maker. So I'll parallel these two. This one will be our in circuit all the time. This one will be the one that gets switched in and out. All right, here it is stuffed. When you do this, you got to make sure you pay attention to what the schematic is really saying. And the schematic in this case is saying that one end of both capacitors are tied to the line that goes to the output tube plate. So they're both connected there all the time. The 0.01 capacitor right here is connected to ground all the time. But the 0.015 is switched, and when it's switched on, its other end, its free end, is connected to ground, and it's put into circuit. When the switch is open, this capacitor doesn't exist. So what we can do to make sure that we did this correctly is we can leave the switch open, measure the capacitance from ground to the point where it's going out to the 42 tube. In this case, it's right here, this wire right here. And with the switch open, like it is, we should get around our 0.01 microfarads right here, because this one's in circuit. When we close the switch, we should add in a 0.015 microfarad capacitor, give or take, and that should add up, or our capacitance check should then read around 0.025, thereabouts, microfarads. So let's give it a shot. We can make sure that we've wired this up correctly. Remember and to show you the ends, one end of, in my case all three, but in your case hopefully just two capacitors, comes out here and it's connected to the plate. One end of the smaller capacitor is permanently soldered to ground right here. The other end of the slightly larger capacitor goes right here to this connector. So it's switched in and out. And we'll just put our ground lead on there and our positive lead on here on our cheapo ESR meter, and push the cheapo button. It should be around 0.01 microfarad. So that's 9,755 picofarads, which is 0.00975, which is so close to 0.01 that I can't count it. So that means our with the switch open, our 0.01 microfarad circuit is in, or capacitor is in circuit. Now let's switch this to be on. Push this again. We should get around 0.025. And we got 23.9. That's 0.0239 microfarads. So we're in business. This is working. I can put this back in the radio. It's all cleaned up. And again, this is the lead that connects to the plate of the output tube. Here the tone switch is back in the radio. The line going to the plate of the output tube is this guy right here. The other line coming up ties to there, and that's the one that gets switched in and out for the additional capacitance to lower the tone of the radio. Now, I could leave it like that. I could fill it with hot glue. Larry at Back to the Future Radio has found some black hot glue. I haven't been able to, I looked around, I can't find any locally. So I'm going to use sealing wax. It's just a stick of hard wax used for sealing envelopes and things like that. And all you do is you light the candle and drip wax wherever you want to seal an envelope. I'm going to see if I can light the candle and drip enough wax in here to fill that reservoir with black wax. And we'll see. If I can't, I've got a torch. I'll heat it up. Regarding the wax itself, this is what I used. This is a sealing wax stick. You get 4 of them in a little container like this. I got this at my local Michael's store. It's hard wax. It's not for candles or anything. The only, I was considering what are the risks. The risks are that it gets really hot in here, and it might melt the wax, and it'll flow down to the bottom of the case. It might. I don't think it will, though. It takes a fair amount of heat to get melted, and there is this heat source right here, but I'm not sure really how hot this step down this resistor, this power resistor, but I'm not really sure how hot this powder resistor is going to get, whether it'll get warm enough to do that. Maybe, maybe not. It's a risk. I tried to melt the original hard wax that came out of here, and it just put up a terrible stink and smoke, so I decided not to try it. I just went with the wax I could buy at a local store, and it doesn't smell bad. Sealing wax sticks. And here it is, filled with wax. We can make sure that our repair is stuck by measuring, again using the ESR meter. We've connected the one lead to the plate. Pin 2 of the 42 tube, one lead there and one lead to ground. And the switch is open right now, so we can measure the capacitance in that, and it's again our 0.01 microfarad range. So I'll switch that to extra low base and measure it again, and we're at our 0.025 microfarad capacitance again. So our tone switch is in and is working and is filled and looks kind of like it did. It's the only one I'm going to bother filling like that. Because it's the only one that shows. It's just right there, and it would look kind of ugly with those yellow capacitors down in there. So that's a special treatment. So that's the tone switch. All done.